Okay, shall we start? You guys ready? Getting very low voices. All right, let's just start here. We lost another 10 minutes here today. Okay, so just a sense of how many different neurons we're talking here. This is an example from GPT-3. Input vector has 12,288 values. The output vector has the same size. One hidden layer which has almost 50,000 neurons. Just these three layers, if you get together all of them, if you get the numbers calculated here, so 49 going into 228, 1228 going to another 1228, that becomes actually 1.2 billion weight parameters. And then there are 96 feed forward layers, a total 116 billion parameters. That's the number to be calculated for figuring out one word. For every word, it's calculating 116 billion numbers. So at some point of time, and this is something we'll start talking from tomorrow onwards, that is it really economically feasible? What is the value being added to do that much calculation? On the other hand, maybe our mind is doing the same amount of calculation, hundreds of billions of calculation every time I speak a word. It's probably happening back here, right? So either that or our designs are all really very bad. They are very inefficient because we're doing billions of calculations, right? Okay. This is just a quick recap. The next few slides, a quick recap of what we already did. This time, it's just showing into a vector representation. So W is a matrix at one for each, one for query, one for key, and one for value, which is an output. And then Xi is the query word that we are using for every single iteration, right? Very simplistic view. The actual attention head is somewhat more complicated. I have a few slides, probably about 10 slides out there going there, which I don't intend to cover. I already mentioned, I haven't left it there because there's a lot more involved, a lot more mathematics, right? We talked about this when we stopped. Query represents the current context or the focus of the model, whatever the word we are looking at. Key represents the elements or feature of the input data. Majority of the time, the words that we have already seen, but in some implementations on both sides, looking at the words that we have seen, plus the words which are coming in as well. And value is the value associated with the elements or features, which is really the dot product of the query and the key that we get together. What the attention mechanism is doing, it's calculating the weight, measuring the similarity between the query and the keys. How do we do that similarity? It's the dot product or cosine product if somebody remembers the vector arithmetic. So we're doing the cosine product here or dot product. These words determine the level of importance of each element. Higher the weightage, higher the number, lower the importance, lower the number that will come out. The values are weighed by attention weights and then produce the final output, which goes back to the input as the next layer. Similarity that you're doing, you're using the dot products between query and the key. Summing up, we are multiplying by the weights that we were doing earlier also. So this is really what is going on. You calculate a score, you send it to a softmax, and you get the output, which is really a collection of probabilities. So doesn't matter what calculation we are doing. The beauty of this entire design is that whether every action is exactly same for a neuron or from a neuron perspective. Whether you're looking at the attention, whether you are looking at finding out the probability of the next word, it's exactly the same calculations going over and over again. Now, we have not introduced or not talked about it. We'll talk about it in the coming few days. That's where the GPUs come in the picture. Because really speaking, if you think about it, what is going on here is that lot of large numbers being calculated, multiplied, or manipulated, which is what the GPUs are very good for. So the companies which are producing the GPUs, or one company that was actually producing the GPUs, makes the most money out of this new development here. Sorry? NVIDIA. Yes, NVIDIA was the company which was producing the GPUs. GPUs were earlier used in the computers to do the graphical calculation, or if you were in the gaming, or if you were generating a lot of big images, then you were actually producing those or using those. This diagram is roughly what I had captured. Self-attention, somebody asked, but this is exactly the same process that I talked about. You generate the key, query, and value vectors, which is really nothing based on each word, what is prior to it, and what's the output going to be. You compare the keys, you divide the score because in the calculation, and then combine it using softmax, and then add it all together, and you get the output, and then determine which word is affecting or impacting the current query more than the other one. All right, let's just move on here. Self-attention, somebody asked. Exact same thing. If you just look around, I mean, I'm just repeating it here, but that's exactly what is going on. Is it conceptually clear now? And what the goals of the attention mechanism is? I gave 3 examples basically, right? And there are multiple of those. GPT-3 had 96 different type of attention heads that they are looking for. Some of them are proprietary or like secret that they are using, so they don't even tell you what exactly is going on there. But basically, the self-attention mechanism or the attention mechanism is looking at the context of each word and then try to figure out is which word is impacting more than the other. The second example, as I mentioned, was that for if you think about, it's trying to find out where a word may have more than one meaning, trying to figure out which meaning is more meaningful in a way. And then in the third example I gave was that when you have 2 words together, they are supposed to be treated as a common, like Joe and Biden are treated together. All right. Now, based on what you have seen so far, what are the advantages? What are the benefits you think are there? What are the advantages, if any? If we are spending so much money in calculation, there's got to be some advantages, right? So let's look at some advantages. One clear advantage is parallelization. Okay, earlier neural network, which obviously we didn't spend too much time on, whether recurrent neural network or LSTM networks, they were all sequential in nature. You couldn't parallelize them. So there was a limitation of how fast, how much they can produce. So the transformer model lets you run a lot of computation in parallel. Scalability. These models can actually produce or handle large data sets, produce a lot of different inputs, and then basically once you can do that, you can deal with larger data sets, you can produce the larger output or have even larger context windows. The larger context window is the third point here, is a long range dependency. Depending on how big is your context window, you can go back 5 words, 5 sentences, sorry? 5 paragraphs. I think it is. No, it is not. Okay, now it does. Yeah. All right, thank you. Sorry, guys. So depending on what the context window is, that you have a long range dependency. If you have a larger context window, it can go back to not just 5 words, 5 sentences, maybe 5 paragraphs. So depending on how large your context dependency, all of this is coming because of transformers. And then obviously there's flexibility, because once you can figure out the attention head mechanism, attentions, and try to basically compare Joe's and Joe's, Bill and Bill, if you're referring to 2 different bills, which one is referred by which word, obviously it makes your model much more powerful. Now, there are variants of these transformers. Now, some of you may have heard of these. I'm just going to give you a very brief introduction of these things. Now, because we are not going into the details of these things, I thought I'll just introduce, so I just added a few more slides, actually very early this morning. GPT, which is probably the most commonly known, you guys have known this or you know it in the sense that that's an autoregressive model, generates takes one word at a time, can perform few short learning tasks or even one short learning task very well. BERT is the Google's model, which is based on the transformer. It's bidirectional, which means it can look in both directions. As I mentioned earlier, I didn't give the example. The examples were all from GPT, but the Google basically include that its transformer can look on both sides. It uses a masked language modeling rather than predicting the next word. It basically tries to predict the missing word. And because it's trying to predict the missing word, it can look on both sides also. There are benefits, there are advantages, there are drawbacks also. T5 is a specialized transformer which is good for text-to-text translation. What it does is that it basically tries to build the longer contexts in the sense that where words are not translated from one language to the other language just as a word, but as a longer phrases. So it's a specialized transformer which does the text-to-text translations. Comparatively, if you think about it, they all have their different ways of looking at it. The GPT is unidirectional, which is very clearly understood. BERT is bidirectional. T5, because it uses the encoder-decoder mechanism, is bidirectional in encoder, unidirectional in decoder. The decoder is where it's translating from one to the another language. The next row explains you encoder, decoder, encoder, decoder only. The pre-training objective, majority of our examples in this last 5 days came from GPT, which is autoregressive language modeling. BERT, I mentioned, is the masked language modeling. What it does is that it hides one word, tries to predict it. Once it matches with the hidden word, it knows that it has learned that and it moves on. That's the pre-training objective. Denoising for T5, which is really doing the translation, is similar to BERT's because the encoder phase of the T5 is exactly same as the BERT learning. The longer spans of text, because it's not trying to translate word by word, it's translating sentence by sentence or even larger, the concept by concept. That's what it is doing. Task approach is, again, it all depends on what the goals were. The size is another important factor of comparing the two. BERT, I mean, again, this is an old one. Gemini has improved the BERT big time, but the BERT had 340 million parameter. GPT was way ahead. This slide is pretty old, actually. T5, because it's only limited itself to the translation, it can handle up to 11 billion parameters. A lot of Indian languages are also now part of T5. So you can take a Spanish text and convert it into Telugu, for example. How well it will do, I'm not sure. I know Spanish a little bit, Telugu none whatsoever. So I'm just giving an example. So a lot of different variation on the transformer architecture. As it stands today, if you ask me, this is the most promising architecture that we have in the deep neural network. Will it remain the same a year from now, 3 years from now? I don't know. There might be other researches which have not yet been published. Actually, there are major players who started with the deep neural network, and then on the attention side and also on the transformer side are already being a little bit skeptical of having this as the future. So there is an understanding that something different, either both from architecture perspective or from the conceptual perspective, will have to come fairly soon. Okay? All right. So let's just very quickly summarize what we did in terms of the transformer. We learned or looked at attention as a concept. The whole idea of attention is enriching the representation of a token by looking at the contextual information. We saw the example of these. We also saw the example of different type of attention heads. I gave you 3 examples. One was the exactly looking at the incorporating contextual information. Second was that if the word has different meaning, trying to figure out which meaning is more meaningful here, or by combining the 2 words. GPT-3 has 96 different type of attention heads, which means there are 96 different type of information theoretically they are looking for. Not all of them have been published, some of them have been, some of them have not been. I gave you an example of just 3 at this point. The result would be that the embedding for each word will be different in different context. So something I had mentioned this earlier, bank has 2 meanings. So you would normally not expect that the bank in the GPT-3's meaning space will have only 1 embedding. It will have 2 embedding. It may have more embeddings as well. The contextual embedding is what is important, because just the embedding of bank is not relevant. Bank in the context of what you're looking at right now is what is important. Some of it has been studied, but the meaning space of the model has not yet been fully explored. I mean, researchers are still trying to figure out, trying to make sense of it, trying to find out where exactly the meaning is, or the latent space or capability that was not explicitly trained appears from. It is still an active research space. Any questions? Yes.
So nowadays computers are equipped with a special chip called NPU, Neural Processing Unit. So firstly, what is an NPU? And secondly, why only laptops have that and not dedicated desktop computers?
All right. Now this is one of the questions which I will say that I have no idea. Okay. This is not my area. I don't know actually. If you want something, let's take it offline. I will find out something and let you know. But I have not really seen too much detail on the NPUs, and I'm not even sure why the second part of your question, that it's on a laptop or not. My laptop is almost 8-9 years old. It definitely does not have an NPU, I can tell you that. So sorry, but if you want, we can talk about it separately. Anybody else? I mean, there's GPU. The Google has come up with its own called TPU, which is the Google's own response to challenging NVIDIA's kind of position or monopoly. Yes, but then it does their own, it implements their own software as well. Any other question? Hopefully, which I know or have an answer for. Anyone else? How many of you have played Housey or Tambola or something like that? Housey. So normally they announce a prize saying that those who have not really filled any column yet, right? So I should ask that those who have not spoken or asked any questions. Let's have one of those ask a question here. Anyone having a question? Those who haven't yet spoken or said anything? No? Okay, all right. So this is the section which I do not intend to spend too much time on it. So I'm going to skip this out. Lot of conceptual, lot of mathematics. If you have an interest, as I skip out, you just let me know. We will spend time on it. But basically, it's more math and a little bit more complexity from 2 perspectives. One from math, one from actually not looking at one head, but multiple heads, and then trying to explain that. So this is exactly what it looks like. You saw this version before. There are stacks of transformers that are running in parallel. As the attention head moves, or as the query and key changes, you have the information moving in slightly sideways as well. So long and thanks for, so moves on, long and thanks for all. What you're looking at continues to shift. This is what needs to happen every time. These are the keys. These are also the input, the values, and this is an this is a transformer stack, and at each level, each transformer might be doing something different, right? So it's fairly complicated structure. The next few slides are trying to explain that. Feed-forward network, which is doing the ReLU also. So what it is saying is that some layers, not necessarily all having sigmoid or softmax, that becomes part of the architecture. Why one versus the other? Like someone asked me last week, that's all the research that they have seen that this function performs better, or this combination of functions and layers and number of neurons perform better. That's what it is. If you look at all of these models, that's what the architecture is different. The basics are still remain the same. Layer norm, which was one thing that I did not spend time on earlier. It is only meaningful when you have stacked transformers from one layer to the other layer, and I am not necessarily going into the detail, but if you think about it, all they are doing is defining, if you see that mu and sigma are two moments of the probability distribution. First one, if you see, is like an average. First one is an average. The second one is standard deviation, right? So literally what's going on is that they are computing a layer norm, which is a variation of a z-score, which is something like a normal distribution, trying to find a single number that you can take from one layer to the other layer. Same calculation or same example, but showing exact calculation at a very high level that is going on at different time stamps or at a different time and different stacks. Again, I'm not planning to spend time on it. Basically, multiple blocks, it's repeating in each block. And this is the point I was trying to make earlier, and this is a very recent paper which they say that the attention head is shifting the focus from here to another parallel stream, which is what the same thing we saw earlier, that it was here and it was trying to find out where exactly it's getting attention from or which prior stream it's getting attention from. So literally what they showed is that you can view attention head as moving information from one token into the neighboring token or tokens. Excuse me. I'm going to skip the token embedding, positional embedding, because this is a little bit of a math I wanted to talk about, but we can skip it. Go over it. If you want to have a conversation, we can have the conversation in the next couple of days. But this is basically, if you think about these, about 10 slides or so, this becomes the final transformer model. They're talking about how exactly what we saw before we took the break, which is the one example of key value query pair gets transformed in two different ways. One, when you have a multiple stack of transformer, and then you have in parallel whatever the number of context window is. If it is 8K, there are 8K such stacks of transformer working together. So that's exactly what we are doing here, and we are getting a few examples here. All right, so basically, as I had said earlier, that I'm not going to spend time on it, I just walked over it. There are probably about 12 or maybe 14 slides that I skipped here. Intuitively, what they're doing, as I said, is stacks of transformer and in parallel. Thing that you need to learn about was the finding that was done a couple of years ago here. This one. Because what is going on is that you're shifting the attention when you're trying to find out is from one stream to the other stream, which is what is literally what was observed or what was intuitively figured out. So keep that in mind. That's what is happening in parallel when you look into it. Okay. There are a couple of other things that we have mentioned in passing. One referent here is unembedding layer. I'll just give you a little bit of an intuition before we actually go on to this page. When I said in the very early days, like second day or maybe third day, that learning is both weights and biases, but also the interconnection between the neuron. Then when we were learning either on fourth or fifth day was regularization, when we said that the intent is not to memorize, but to generalize. And one of the ways in generalization was regularization. Third thing, if someone remember, was dropout. And I said that the dropout is basically when you drop out the output of a neuron or ignore it. In the transformer architecture, what they have is an unembedding layer also, which basically does the same thing. Rather than dropping out output of a one single neuron, what it does is that it has an unembedding layer, which means in the meaning space that we talked about, it may take one entry and unembed it, which means saying forget it. So it can do that as well. That's also part of learning. Think of it this way, it discovers that, okay, whatever I had done up until so far for this particular token is all wrong. So it unembeds it. So that's also part of learning. Okay? All right. So, any questions? I'm at Q&A.
Can you give us some idea about what is happening after the stack of transformation, like that language modeling? What's happening?
Okay. All right. So I think both of you asked a very similar question. So see, there is nothing new that is happening here. So if you think about it, all the LLMs are doing is predicting the next word, right? When we started on the day one, our examples were so simple that it was easy to predict. And I said that, I mean, in a way, actually, that's what we're going to do this. So it's a good question. We are trying to recap what we learned, right? So what we said is that all these large language models are doing is predicting the next word. And then we said that there is no single word, so each of these words are probabilities. And then it will pick up the word based on the probabilities. Then we said that, you know what, if it always picks up the same answer, it is not necessarily the interesting thing, or it may not be the context that you have. So then we said that you have prompt engineering, which is basically letting the model to know what your intent is, or you want to modify its behavior. All good, right? Then we said that each of these words, up until today I was using the term word, or let's say token, is somehow represented into a space. That space is a very high dimensional space whereby these tokens by their proximity show their closeness to each other, right? Then we said that even though that's the case, and once we started making it bigger and bigger, we said that now there are these sentences where either you have a pronoun or you have a word whose meaning is not very obvious, because the language is such that they have multiple meanings. So within the same goal of predicting this word, now we have a larger problem to discover this. To solve this problem, we said that we use what's called transformer, which is based on the concept of attention. So whatever we talked about today was only trying to make this process more efficient. Eventually, this goal remains same. So what we saw that you had 96 layers of transformer stacked over each other, each of them doing maybe something different. One of them is trying to figure out what is the pronoun referring to. Other one could be that which of the context applies to the bank. Other one could be trying to get together, let's say, what's the bank you have? Punjab National Bank. So it might say that, you know what, Punjab and National and are not two separate tokens. You have to use them all together. So depends on what exactly you're doing. All of these are like sub goals. Your goal is still this, to predict the next word. That still remains. This is still solving the problem of understanding the context. Does that answer your question, or you want to modify it? No, there's nothing called large language modeling head. Attention head. This one? Which one are you referring to? This one, okay. All right, fine. Okay, so you're saying this word basically. Okay, yes. So in some way, shape or form, it is this part. The end of the result is still discovering this, right? The transformer is the one to understand this better. And for every word, that's where I mentioned in one of the earlier one is that to predict this word, there is 116 billion calculations being made, which is all happening here. So it's a lot of math going on there. Okay. All right. No, we got a little too further ahead of us. Any other question? This was a good question just for complete. Yeah.
As this math is totally new for me, sir, what we are getting in the key theory and value, as we have to calculate the dot product to calculate attention head. So what we are getting in query, value and key means we are getting numbers or words that we have to calculate the dot values.
Okay. So two separate things here. So first thing to understand that each of these tokens are represented by a vector. Those vectors are the numbers, right? That's what the position space is. So every token is represented by a number, right? And then what happens is that the learning tells that, and which is what the transformer is doing is, so the sky, the blue, for example, right? So we don't know how these numbers are getting calculated or assigned by the language model, but what was figured out is that the sky and blue, there will be some affinity. How do you figure out? You take this number, multiply the two vectors, sorry, and then take a dot product. What comes out here is some numbers which seems to be indicating the blue is related with sky. That's all it is. Now, this vector is randomly assigned numbers, not randomly, assigned numbers by the model itself. That's what is going on. Right? Now, when you are looking at this word, each word by its turn becomes a key. Whatever preceding it, becomes a query. What is preceding it is a key, and then you update the values based on the dot product, and then it becomes input to the next layer, the next layer, the next layer. Right? These embeddings, these vectors could also be changing. As a matter of fact, as I said, that there's an unembedding layer where some of these things could be dropped also. I mentioned here that just one vector, the blue may have multiple vector embeddings in the space, like bank is. The blue may also be, because if you think about it, blue is just not the color. If somebody is sad, that feeling is also described as blue, right? If somebody has got, somebody's got hurt, right, or beaten blue, like heavily beaten, that is also the blue is used. So blue in itself may have multiple embeddings possible in the space because it's a different use case, right? Okay, any other question? Okay, feel free to think about it or just ask. So let's see. We're going to be kind of concluding the generative AI portion, and then we'll go on to the use cases and the other socioeconomic kind of repercussions. So let's see the recap here. When we started, there's a traditional machine learning and there's a generative AI, right? So let's try to compare them into 5 different ways. The primary task of traditional machine learning generally was classification and regression. All kinds of models exist there, right? A lot of techniques out there. Some of them are kind of straddling between data science and machine learning because they are all together overlapping with each other. Generative AI primarily is generating some new content, audio, video, text, whatever the case may be. While doing that, and we saw the example, it can also be doing like summarization or sentiment analysis, because they can all be expressed as the same problem as generative AI. Traditional machine learning definitely needed the label data, because first it is to be trained or told, whether it's classification, regression, or any other kind of a problem, it required label data, and which is where actually the drawback was, because trying to get the label data was a problem. Though companies got creative, I gave you the example, CAPTCHAs are all the label data sets. Every time you were tagging your friend, your family member in an image, you were providing them label data, right? Generative AI models can work with unlabeled data. As a matter of fact, you would see that pre-training is all with unlabeled data. So that's a huge advantage. The output, traditional machine learning model is doing classification or a prediction. Just like as I said that you can create a regression model of GDP growth. If you got the model right, you may be able to predict what's the GDP growth is going to be next year. This can be expanded to anything. People have built model where they have said that, let's say you are maintaining a huge data center. So there are models that are going to predict that which CPU is going to fail, which hard disk is going to fail, etc., etc. All kinds of models can be built. Generative AI is usually creating new data or synthetic data, right? Model complexity. Traditional machine learning, it varies, but generally they are simpler compared to the generative AI. There are usually more complex models in generative AI. Interpretability, in the sense that if the model is giving me a result, can I go back and figure out why it gave me this result? In traditional machine learning, it generally is easier. You can go back and figure out why the model is saying what it is saying. Not so easy with generative AI because we do not know a lot about how the neural networks are working. Though people are learning. I mean, the researchers are going after, that's how we know how the semantic space is, how the word space is, that's how we know how attention is working. That's how we've seen the examples of that it not only has the tokens that we understand as word, but also has some tokens which we don't know why it's creating them as a token. So there are a lot of things which are not known, a lot of things that we are trying to figure out and learn as we go along. Okay, let's continue to look at a few more dimensions of this. Generative models are generally more creative. Traditional machine learning was not doing anything creative. Generative AI is writing, or at least attempting to write haiku poems, not great, not like Shakespeare or not like Kalidas, but they are doing something. People have used the GPTs to write stories. Stories are not really very good, but we are there somewhere. But at least what they are doing very well now is that they have learned the style of, let's say, Shakespeare. So if you provide what researchers are doing right now, your own story, and say, can you rewrite it as if it's written by Shakespeare? It has learned to do that fairly well because it has figured out the style of one author. If you give it a story, then it will convert it into the author. So it can change a few things. Unsupervised learning, all right, one bad label there. I'll fix it later. Generative model can learn without labeled data, which is really the most important part that we are dealing with it. Dimensionality. Now, I have mentioned this earlier also. In typical machine learning, the focus was always on reducing the dimensionality. We were always trying to reduce the dimensions of data in which we are dealing because that's what the mathematical modeling makes it easier. You know that if you're trying to do regression analysis, the focus is that can we get a linear regression function or quadratic function or polynomial. You don't want, so you're trying to reduce the number of data sets. You start your data analysis with 50 different columns of data. You're trying to avoid where, okay, this one is not necessarily, it is very sparse. We don't have data available, not use it. Then you try to find out that, okay, this is same as this column. So let's not, so always trying to reduce the dimensionality. Generative models can work in high dimensional space, no problem. They create their own higher dimensional space. So that's really always a problem. Always the benefit of the generative AI model. Evaluation, the quality, that's very subjective right now. There are no analytical, formal, mathematical way of comparing one model versus the other. So a lot of open research areas that we are currently working on. Okay. Before we move on to the applications of generative AI, which is literally the last topic for today, trying to get into what can you do with it. We just summarized a little bit. I just spent like, I think 2 slides or 3 comparing the traditional machine learning with the generative AI. Any questions? I did not use the term expert systems and things like that, but if you think about it, they were all supervised learning model, like an expert codify their knowledge and then you somehow represent it and then you also then use it to display or come up with a result. So, any questions so far? Yeah.
Just an observation that, you mentioned about evaluation, very subjective, like how to find out how was the output of that whole thing. Like only humans can understand or?
Okay, so two things there. First of all, when I say evaluation on this slide, that's not what I meant. The evaluation here was that the comparing two models and the quality of two models, not the absolute quality of one model. But inbuilt comparison there or evaluation there is your answer as well. So if you think about it, from that perspective, the reinforcement learning is one way of evaluating the quality because that's what is going on. Because in reinforcement learning, you're telling the model, did you do well? Did you do good? Did you not do good? You're penalized. You're getting 60 out of 100 or 50 out of whatever the scale is there. So from that perspective, for one model, because you're providing it feedback, you're basically trying to improve the quality. That's always there. Similarly, something that we talked about earlier is the GAN models, which are that there's a generator model and there's a discriminator not model. There's generator module and a discriminator module, and they are always telling the discriminator is always trying to finding fault with what the generator module has produced. So internally, these models are getting evaluated and improved on. This specific bullet point was if you have two, there is no formal way right now to say that this model is better than this model. You may have trained model A, somebody else may have trained model B. Now, I, as an independent observer, I have no way of saying which model is better. We haven't yet discovered or learned that. I mean, yes and no both, because at the end of the day, if you think about it, whatever we are doing, these are all human decisions, right? It's just that we're trying to figure out.
What is the better quality output?
That definition is on us to define, yeah. But and that's one of the reasons, because we are not able to define, we are not able to even implement it. It's the same thing, right? It's a very interesting question because in the next few days, that is what we're going to talk about. So I'm going to take an example. We're going to go into the applications of generative AI, then we will take the examples which are out there, and we will look at from ethics perspective, from the risks perspective, from biases perspective. So in a way, if you think about it, we will be evaluating these models, but all those cases will be evaluation of these models in a specific use case. And even there, we are not sure. So where the current research is to identifying where there are moral problems, ethical problems, biases issues, risks, other societal risks, the issues related, the assigning of responsibility, all of these kind of situations. I mean, there are the assignment of responsibilities even today. If you think about our legal system, when something untoward happens, the laws determine the responsibility of who is responsible for this behavior or who should be punished. So same kind of issues will come in when we let the models take action on behalf of us. That who's responsible? Is model responsible? Is the model developer responsible? Is the programmer responsible? Who's responsible if the mistake is being made, right? So these are the issues we're going to talk about in the next few days. But good question. Anybody else having a question here before we go on to the applications? Okay, if you don't ask a question, let me ask a question. What applications do you have in mind for generative AI? I know one of you were doing the edge detection, right? Or something similar to that, right? What about others? What kind of applications do you think if you had access to, let's say, the best model available today, what applications would you be using it for? Come on. Virtual? Sorry, virtual what? What is it?
Virtual friend, sir.
Virtual friend.
Yep.
Oh, virtual friend. Okay. All right.
High scope in solar industry, I guess, or like PV installation, solar installation.
Uh-huh.
Basically, it is installed on rooftop.
Uh-huh.
So, like it should be aligned with the direction of sun.
Yes.
So, in there, we can use it to get it aligned.
Okay.
Also, it requires like a regular cleaning, and it is very not much feasible to go like on the rooftop over that top.
So here's a question. I mean, that's a good example, but let me ask this question here, right? A couple of years ago, I actually taught a course on blockchains, basically cryptocurrency and blockchain. There were a lot of examples in various places, a lot of them from India, where people said that, oh yeah, they're building an HR system using blockchains. I had to really ask that, but why? I mean, I gave an example of Occam's razor, right? I don't know if any of you looked into it. If there are multiple solutions available, pick up the easiest one. So the problem that you are pointing out are genuine problems, right? But I'm going to say that those problems have already been solved without using the generative AI, for example. One of my job before coming to the academia was at Bank of America. Bank of America constructed a building 10 years ago, which already had the window shades, which were automatically tilting depending on the temperature and weather outside, whether to let the sun rays in or keep them out. Because if the goal is to heat up the building, it was letting the sun rays come in. If the goal was to keep it cool, it was blocking the sun rays out. And that was being done without generative AI. Now, theoretically, you can say there was intelligence built in. Yes, because there were sensors inside, there were goals, whether you want to raise the temperature or lower the temperature. And then there was the mechanical motors, which were actually controlling the angle of the shades. All of that was done. And it goes back to the question, what is intelligence? 10 years ago, even in America, that was great. Now, it was great for two distinct reasons. One, it was first of its kind. Two, even though it's known, not every building is doing it, because this was a new building, they were able to do it. Older buildings are not equipped to do that. So it's not happening. First time when it happens, it looks like this is magic. Once people figure out how is it done, then it's just a matter of every building getting renovated, and every building then calculates, okay, what's the cost, what's the benefit? Will I recover the cost in 10 years, or it will take me 50 years to recover? If it takes 50 years to recover, the people who are living in that building says that we're not going to be here for 50 years, we're not going to pay for it. So it doesn't work. So, I mean, my example, what I'm saying is that it all depends on it. But think of an application that you cannot do today with the today's technology, and that you can use to do with the generative AI.
So we can use Gen AI in education for education purposes.
Yes.
And for like we can bring back historical figures to life, and so that the students can understand that better. And we can also use it for hearing impaired patients. We can give instructions to them at offices or their official systems are there. So they don't have to feel left out or they have to ask someone. They can go somewhere where it is installed and they can talk through it.
Okay, so you mentioned three things. So I definitely agree with you that education area is one, but let's just go into more detail to see what all possibilities exist. Now, bringing back historical figures. Okay, if you take the historical out for now, right? Narendra Modi created the hologram images in 2014 itself, right? So technology exists. You could create Einstein also, in hologram today. So that one I would say that is independent of generative AI. Even in 2014, it was possible to create a holographic image of anyone, right? So yes, it's an example, but it doesn't require generative AI per se. Your third example was about the people with limited natural abilities, right? That's what you were saying. So that's definitely one where we could say that rather than building the chatbots for people with natural abilities, let's build the chatbot or something like chatbot with the people with limited abilities. So that's definitely one area that I can imagine that we'll do. That's good example, but let's try to think things which are possible now, which were not possible without the generative AI.
It may be used in legal systems.
Yeah.
Like, as a law.
Oh, you mean to say that can it be used in legal system? Yes. So that's another example.
Because there are, like, talking about a law,
Yeah.
not disrespecting anyone's part of words.
Yeah.
But there are a lot of like advocates, so it can replace in future.
Okay, so let me give you two examples, and I have to bring it in topic again, but this is all good. Let me give you two examples of generative AI being used today. In US, it's used for helping in sentencing. I mentioned this earlier as well. Now, helping in sentencing means what? A typical legal case has 2 or 3 different phases. A charge sheet is filed, which means whoever is prosecuting, whether it's an individual or a state, is filing a charge sheet means against XYZ that you committed these crimes. Then comes the defense stage where the person who's being charge sheeted is allowed to give their side of the story, which is a defense saying that I didn't do it, we didn't do it, or whatever the case may be. Then it goes to the determination of the fault. Now, depending on the kind of system, it could be a judge finding fault, or in US, it's jury that finds a fault. Once the fault is determined, then comes the phase called sentencing, which means that it's already established that the person is at fault. Now, how much should he or she be punished? That's called sentencing. So, the AI has been used for helping in sentencing. Now, why that? Because the sentencing laws are never definitive. So even if anybody who's familiar with law, or if you're doing in research, there will be that if you are found guilty, you may be punished up to 5,000 rupees of jurmana and 6 months of rigorous imprisonment. Now, judge has a leeway, whether he gives you 5,000 or 500, 6 months or one. Lot of time you may have heard of it that you are, the person is found guilty and was taken in judicial custody till the court rises, which means that the judge may be giving that judgment at 3:45, the court rises at 4 o'clock, so this person's punishment is over in 15 minutes. So even if the law allows up to 6 months of prison, judge might give it only for 1 day, right? So the AI is used in helping the sentencing, so that's one area. There are issues with that. We're going to talk about that in the next couple of days. It's also being used to actually create a case note, like either from the defense side or from the charge sheet side. The examples there were that it just made up everything. It made up the laws, it made up the cases, it made up the names, and it was a totally bad document generated. So theoretically, yes, it can be used. Is it there yet? No. I mean, there are published papers which actually are saying that the ChatGPT was used and has produced a very bad output. I'll see if I can get some examples for you, but yes, legal cases, yes. Has it been used successfully? Yes, in one case that I'm aware of. No, in one case where it's not been used. Even where it's been used successfully, we're going to examine it from the perspective of bias and the ethical and morality of the situations. All right, one more example before I go to my slides.
Sir,
Yeah.
Used to generate meta world where there can be a bots like you and me having their own intelligence, and a person from real world can intersect in this simulation with his own intelligence and can live the moment.
Okay, so you bring in a lot of different things. So metaverse is a separate technology. Yeah, metaverse, yeah. And it exists without generative AI as well.
The use of intelligence and bringing a real human into that picture.
Okay, who is a real human? Sorry? No, I mean, these are all very deeper questions actually, right? Who is a real human? Am I a real, sorry?
We all are in a matrix.
No, that's not what I'm saying. So you don't make it more complicated, because what you said can be broken down in 5 different ways or 5 different things, each of which are, in my mind, are undefined. So if you take just one simple example of who is real human, am I the real human? Are you the real human? Is the person who is driving a car outside a driver real human, or a person who is cannot see is a real human? It's very difficult to define who is a real human.
It's like the world of robots, and we are the outsiders.
Okay, now we're going into all make-believe world. So
If we classify the species, like there's species like it works on X2 and there's species which works on like
even then the world is very complex. So in one of my hats that I wear nowadays, right, I work with the people who are intellectually or developmentally disabled. Yeah.
so you mean God is a real human and we all are the gods in this
I'm not even going there. We're not even talking about that. So if you think about it, yeah, it's okay. Are you being discouraged to ask the question? No, it's fine. All I'm saying is that when you are trying to establish a problem, see if you can define the problem itself. What I'm trying to point you out is that in your setting up of the problem, there are a lot of undefined sections of that problem. It's very difficult for me to tell you who the human is. Who are we trying to model as human? Right? Is a 6-month-old baby human or not? A 6-month-old baby's world is very different from your world than my world. So who are we calling human? Right? It's a very open question. So, and it's a both philosophical question, ethical question, moral questions, all kinds of questions rolled into one. So we're not even going there. So if you think about it, Google had discovered this entire thing. The Google researched everything. They never actually brought it to the people until ChatGPT came on board, right? Why? Because they were trying to deal with all these problems of not giving the right answer, people thinking that whatever they see coming out of the model saying as absolute truth. It's not. We don't even know. See, these are the questions we're going to talk about in the next 3 days. Where is the problem? Or is there a problem? But there is other part of the question in the sense that the generative AI, because it's generating, can be used to create virtual worlds. Yes. So if you are a gamer, how many of you play games on computers, right? So generative AI can be used to create more realistic worlds, more futuristic worlds, because that's all the generative AI does, because it creates. If you're creating the world today, a game designer actually visualize the world. You can use generative AI to do that. Rather than you creating it, you specify, you describe. Let generative AI create the pictures. Generative AI can also be used to create worlds on the fly, which means you playing the same game as against someone else playing the game, they may see totally different worlds with the basic functionality. So a lot of things that you said are possible, should be done, or is being done today, but some of them are not yet well-defined problems. Okay, all right, so let's just take a few examples. Some of it are based on the case studies that I had pointed out earlier. Arts and design, that's one area generative AI is being used. Visual arts, music and audio generation. Many of you have seen probably, some of you mentioned that you have used these kind of examples. AI generated art, graphic design, AI composer, sound design. I'm not going to spend too much time on it unless there's a question, just ask the question. I have some slides where I basically talk about it. AI generated arts, generally using GANs, because what's going on is that generator generates based on the input and the discriminator basically evaluates how well it is, and it keeps on going automate, keeps on going, criticizing till it gets an optimized output, right? The process of creating AI generated art, if you think about it, I have this slide in some cases, not all cases. The basic flow is same. You train, you first collect the data, supervised or unsupervised, you train, you generate the new one. Human curation, that's what we were talking earlier. Will the human be responsible? Someone is going to tell us that, is it a good, is it not good? This is called the reinforcement learning human factor, or RLHF, reinforcement learning by human. I'm not sure what the F stands for. Let's say human factor, RLHF. Okay, so AI generated art. Let's look at a few other examples. Music and audio generation. It's happening quite a lot. Environmental sound, the ambient noise is being generated. Character voices, the game NPCs, what their voices could be, they were already being generated using electronically. You can make them even more authenticated, natural, innovative, whatever you want to call it. Futuristic or imaginary sound, that's what I meant by it. So you can have the you can have a character built how a Martian would sound like, and let the game character has that kind of sound, right? Another example I had it is generative AI in healthcare and biology. Lot of different areas. Drug discovery is something that is very actively being researched for from all different areas. I may have another slide on this at some point of time, but in general, understand this in the sense, trying to find the drug candidates, trying to find the interaction of the molecules, trying to find the feasibility of a specific module. Medical imaging, a lot of it is happening both in the stage where you're trying to detect is not the right word, interpret an image, but even before actually generating the synthetic images. Clearly none of you are doing medical, but are you familiar with any of your friends who is in medical world, being doctor or anything? How do they do their experiments? What do their labs look like? So there are two kinds of labs, right? In some cases they use cadavers, right? Because they have to experiment on people before they can operate on a live body. Then there are radiologists, or the people who are working with images. They need images to experiment or learn, right? Lot of ethical questions come in. Can they use yours and mine's images and x-rays in the lab? Yes or no? I mean, yes they can, but unless I give the permission, they can't. So nowadays the generative AI is used for synthetic data generation, for doing the experiments, to be used in learning, to be used in examinations and things like that. Personalized medicine is another big area where pharmaceutical companies are thinking of generating designer drugs. So they could build a drug for you specifically. Right now, if you think about it, each drug has the problems or side effects. So if you take 3 medicines which were not specifically done for you, you may end up having side effects. So one of the area where pharmaceutical companies are working on, can they produce the personalized medicine specifically for you? That's another area where they're using. I have a more detailed example of the drug discovery. Again, you're reducing the trial and error by lot of information that is done in real life, by letting it be done by the language, by the model itself. So it helps reduce some trial and error. It actually speeds up. It actually reduces the cost. Has it been used effectively, successfully? Still a questionable thing. They're doing it. Whether we don't know in the long term, this will be something that would show up as a very effective use case or not. I talked about medical imaging. Well, I think I kind of covered all of them. Personalized medicine, also I think I covered this. Now, personalized medicine is basically using your individual data, electronic health record. So anytime, every time, if you think about it, India is not there yet, even US is not there yet fully, not in a unified way. But imagine if there was a database that has every single time you fell ill, every single of your tests that was ever done, every single medicine that you ever took, then in a way the model can build you virtually, not a friend one of you were looking for, but virtual you, and eventually can say that if you have this problem, this is the best medicine for you, because it has all the history of all the tests ever done for you, every time you fell ill and every medicine that you have taken. So eventually it can generate a medicine for you, right? So that's possible. There is a related science that's going on here, which is really, there is a group of people in US, multi-billionaires basically, who are working on anti-aging medicines. Basically, they're trying to see, can they remain youthful for whatever time they want to be. All of this requires you as an individual, your entire history, your entire genome sequence, and then a lot is going on, right? So that's one way on the personalized medicine. Even if it is not your individualized medicine, there could be treatment optimization if the model knows your history. So actually, I will say that more than virtual friend, probably this is more likely that we have a virtual you being created. Mentioned about the genomic analysis, predictive modeling is again very experimental, but it's being mentioned about it. All right, let's move on. Education, some of you mentioned, that's a very, very positive or actively researched area that's being worked on. Two ways to look at it. Language learning, that's an easy one, in the sense that because natural language processing is one of the reasons why the generative AI came into being. So conversational agents, a lot of this is being done. One other thing, if you think about it, at least in US, even here it's possibly can be done. India also has a 3-language policy. US has 2-language policy. So other than English, you are expected to learn one more language while you are in high school. So one other thing that they do is it called embedded learning, which is really not the embeddings we had seen, but embedded learning was that spend a week or 10 days in the country whose language you're learning. So if you're learning French, you either go France or you go to local France. I don't know how many of you know or not, the Canada basically has a French Canada and an English Canada. So you go to Canada, which is a French area or French state, and then you learn French there. If you're learning Spanish, you go to one of the Spanish-speaking countries, etc., etc. Language learning is something that can be done by creating an embedded space where you're interacting only with characters who are speaking, let's say, Spanish, if you're learning Spanish or Telugu or Malayalam or whatever the case may be. Personalized learning content. How many of you are familiar with Khan Academy? Right? Khan Academy is experimenting with personalized learning content. They have a system or a model called Khanmigo, where they're saying that we are building a friend or amigo or someone who can help you based on what you are learning and what you are trying to do, creating the personalized learning content. To some extent, which is more related, is adaptive learning path. That's Khan Academy was already doing, in the sense that you give an introductory test and it figures out a path for you or individualized path for you. That's another possibility in the education area. I think I talked about language learning. Yeah, it can give pronunciation feedback. It can help you build vocabulary. It can correct the grammar. It can provide cultural context if you are making a statement or a sentence. All of it is possible today or is actively being worked on, and is one of the few positive applications that the generative AI can produce. Think of it. An hour ago I said that how much calculation that is going on, right? For each predicting a new word, we are doing hundreds of billions of calculation. We have to find out some use cases whereby it is all meaningful. Otherwise, right now it's just cost. Several $100 billion, close to $1 trillion have been spent by companies to do this. I'm not sure how many of you are keeping track of it or not. How many of you are familiar with nuclear energy? What is nuclear energy? A power plant, a nuclear power plant. How many of you have seen a nuclear power plant from distance only? Has any of you seen?
Most of us have seen that web series
Okay. Aye. Where I am from in UP, actually, so we had a nuclear power plant very close to us. So every time I pass by it, you can see it. There's one in Aurora, near Bulandshahr, right? There's a nuclear power plant there. US had stopped making new power plant. Even India is not making a new nuclear power plant. Aurora was probably the last one. There are a few in South India as well. Partly because of the risk, like Chernobyl. That's what US did. You know who is buying the nuclear power plants? Microsoft did. Google's doing it because their power needs are so much that they can't find from any other source. So Microsoft has recently bought a power plant which is in US about 150 miles from my home. It was closed. It was not being used. Microsoft has bought it. Why? Because the needs of electricity is so much to run these language model that they're seeing in few years future down the line there's no power available. So there has to be some effective use cases to justify a nuclear power plant to generate or predict the next word. Right? There has to be some good use cases. Okay, all right, so language learning. Let's move on to the next area. Business and finance. Again, business and finance is one area where any new technology gets sold first and it gets sold for all wrong reasons. So it is what it is. Marketing and advertising, I mean, a lot of it is happening. Will it replace the creativity? Probably not. I mean, being creative is very, very useful. I can give a lot of examples where the creativity beats any technology. But on the other hand, the technology can make creative campaigns even more creative. That's always possible. So one of the way the marketing and advertising is happening is the personalized campaign, dynamic content creation, because if they know who you are, they can feed you the content that is specific to you, your taste and things like that. Right? Now, just to give an example here, not necessarily the generative AI, but where the technology combines with creativity works. So, how many of you, I mean, I think you're all familiar with McDonald's, right? They're all here, and the Burger King also. Those are the two big chains, basically, that there are smaller ones as well, but in the burger space or the fast food space. So what the Burger King did, and without using generative AI, I'm just giving you an example of combining technology and creativity. When the mobile apps were out there, so you could find location, right? So if you have a location and if you have the intent, which is very important in converting someone from marketing to someone to actually having actual transaction being happening. So Burger King carried out a campaign a couple of years ago where they said that if you are within 50 meters of McDonald's and place an order with Burger King, then you're going to get a very special deal. So think what they were doing, because they can locate you where you are. They were able to find someone who has a high intent. Are there any marketing students here? Okay. So you know that if you can figure out a customer with high intent, that's like a gold mine, because then you have only one step, which is the conversion of that intent into a transaction. So what they did is that they said that if I can locate, or if we can locate people who are within 50 meters of McDonald's, which means they are about to make a purchase at McDonald's, send them a message saying that you order it right now and you're going to just get like it for 10 cents or 1/10 of the price or whatever the case may be. And that was a very successful campaign. There were people walking into McDonald's but placing an order for Burger King and then walking out. So I'm saying that there may not be a direct example of generative AI, but you can use it to combine the technology with creativity and come up with it. All right, so outside the marketing, then financial forecasting. That's something very actively a lot of companies are using the generative AIs for. I mentioned it earlier, the 10Ks and 10Qs, which is really the publicly listed companies need to file their statements every quarter and every year. Those are used for learning about the company, figuring out all kinds of information that's possible, predicting their growth as an individual company, as a market segment, as an entire market, generating those reports based on the data. That's another possibility, but then it doesn't necessarily require generative AI, but you can always do that. AI chatbots are very common. Many companies have started doing or utilizing them. Can someone tell me, we talked about it earlier, what is an AI chatbot versus another or a regular chatbot? A typical chatbots have been there for 10 years, are following some kind of script or a decision tree. You'll ask a question and then take a path and all the way down here, right? Whereas the AI chatbots are based on generative AI. Given certain basic parameters, they should be able to converse and be able to deal with any situation, right? So that's the AI chatbots are doing. Here's a case study. I'm not going into the detail. This is a Walmart's AI-driven marketing. There are some examples. We'll keep coming back to it, but dynamic content creation, that's happening a lot. A/B testing, that's what you can do. You can generate multiple of the same thing, like multiple offers being sent to different target customers, and then figure out which one is working better, which one's not. Contextual relevance, I gave you an example about the user location and the intent as displayed by, because you're walking into a McDonald's, you're probably intending to buy a burger, so give you an offer right then and there and place the order. Emotional targeting happens all the time. Generative AI can only make it more relevant. Financial forecasting, AI chatbot, we talked about it. Some new areas. Virtual and augmented reality, we talked about it, virtual worlds, right? Basically for gaming, can give you more adaptive content, more realistic content, more engaging content. It's possible, right? Climate and environmental modeling. This is something which no one mentioned yet, but that's one area where the generative AI potentially can be used, because one of the limitations we have today about climate and environmental modeling is the amount of data that we can process. Now, we're building this massive hardware, massive structure. Hopefully, we can look into climate patterns. The fact that these patterns are not understandable today because of the limitation of our closed form models. When I say closed form models, means we are using equations that we understand, that we can use. We have always been studying the climate and environmental environment based on the concept of reducing the dimensionality, because if we are calculating by hand or by computer using the known mathematical equations, we are always trying to reduce the dimensionality. The large language model, as we saw, are very good in working with numbers in higher dimensions. Our examples so far were the numbers were representing the words. These numbers theoretically can represent anything. So if you think about it, if you generalize it, we have now models or systems that can work with numbers in a very high dimension. So there's a possibility that we learn about climate and environment in a lot better way. Robotics and automation, no one mentioned this yet, but there are generative designs that can happen. Robots can be trained to work on generative AI models. That means that, scary part also, that they are not anymore taught one task. If you think about it, robots are not new. The robots have been there for 50 years almost, right? In US consumer market, I don't know here, do you have the robo cleaners or anything like that in Indian market? Not yet. So there's a company called Roomba, 10 years ago, that came in, which built the robots. So there's a cleaner that is a robot, basically. It goes and cleans the stuff, whether it's your house, whether it's your pool. So a lot of these cleaners are out there. There are robots out there which will mow your grass. So you leave it out, it will mow your grass. So the difference in the generative AI is that all these robots were taught one task. General Motors have been using robots to do tightening the bolt. So there's a robot, its only job is that every time a new part comes, it picks up a bolt, it tightens it up, moves on. So now you can potentially build the robots which can do more things rather than just being trained on one task. So there are things which project that I do to one of my classes to predict the use of AI in hospitality industry. Not sure if I saw it here or not. Robots are replacing in US the human waiters actually. So you place the order, a robot brings your whatever you order to your table. Robots are replacing if you go in a hotel and you ask for, let's say you forgot your toothbrush. So the toothbrush is delivered to your room by a robot. But all these robots are like one task or limited task robots. There's no generative AI capability. All that they know or all they have been programmed with. I ask for a brush, somebody on somewhere says that, okay, go to room number 301, deliver whatever that is. So robots only knows that how to get to 301, which includes actually using an elevator also. So it comes there and then you get, in a way, a notification that the robot's out there. You open the door, you pick it up, it goes back to its station. So one type of training that can replace with generative AI with new types of training. Dynamic word generation, we talked about it, adaptive environment, procedural content generation, actively being worked on. Manufacturing, I think I mentioned this to some extent. Not my area, so I can't talk much about manufacturing, but if anybody here is in production management or operations management, you should probably be knowing a lot more about it. This is probably something that I can't talk too much about. I have no idea. All right. Something that will take us to what we are going to do in the next couple of days is this part. There are a lot of challenges. Bias and fairness, I've mentioned it multiple times, not defined it. We're going to define it. We're going to see what the challenges are. Privacy and data security, huge problems. We touched upon it a little bit in terms of the corrupting the prompt, corrupting the model. There are a lot of things that have happened. We have seen the issues with data security. The large language models have known to unknowingly share secret data or the secure data or the private data. There are intellectual property and attribution issues. That are they stealing intellectual property? Are they copying work that they shouldn't be copying? So a lot of these are unknown areas. So we have to think about those as well, and those are some of the areas we will talk about in the next few days. Okay, any questions? We spent like last 20 minutes in talking in terms of a lot of potential areas. I also mentioned that there has to be some good areas to work to justify a lot of money. Hundreds of billions of dollars that have already gone in and will probably continue to go into this area. Are we ready to use it? I mean, right now, many of these companies are all basically losing money. Every time they predict a word for you, it's probably costing them few rupees in Indian currency, literally. So if they're giving you for free, they're just trying to get you used to it. Eventually, they'll all cost money. Or we have to find use cases which justify this kind of any questions in terms of we summarize what we are and we look at the applications and we look at a few problems or issues that might be there. There are no regulations. you have seen that seen it's using AI. It's okay. I mean, sometimes you went to this place. I'm not sure your specific use case where someone from good intention said, okay, I'm take away the bad part of your X-ray and only show you the good part. I don't know how much value is there. So I'm not sure if I followed your question.
Important on AI. Like, I don't remember the exact name, but something has been ongoing discussion in the US Congress, which was headed by Sam Altman, and it was unilaterally supported by both the left and the right. The idea was to regulate AI. However, its slightly sinister interpretation was the big players like Google, Microsoft, etc. want to regulate AI so that small open source tools cannot grow and compete with them.
Okay. So there are a lot of things that you said, again, depending on the specificity. US Congress, Sam Altman cannot do anything. I mean, that's an individual, basically. He doesn't have a role in the government. But yes, there are a lot of stuff is going on. Some of it is good, some of it is not so good, some of it is. And think of it, when an individual or when a private agency is doing something, it's not totally altruistic, right? Or when the charity happens, there is some motive behind it. Some altruistic, some may not be that altruistic. So my point is not that there is no regulation. My point is that the regulation is missing. And no one knows what the right regulation is. And there's always, and this is not unusual, whenever there is a new technology, nobody can predict it and have the rules and laws in advance. We don't know that, right? Now, there's always a public policy question. Should you encourage innovation and then regulate it, or should you regulate it from day one and stifle the innovation? So that debate has always been there, and in every field it's been there. Any other question?
How an message of AI is correlated with water crisis?
So how is what I missed the first?
One word generation
Yeah.
is correlated with water crisis.
I don't know how it's correlated, but if you think about it, like, I mean, if we are using a lot of energy, somehow it's using the water also. And water is used even today, actually. Even if you leave the generative AI out, all of these companies have massive data centers. Google has a lot of data centers, right? And they are using water to cool the heat. They generate the heat, a huge amount of heat. I mean, their data centers is huge data centers, like millions of computers in one location, and it generates heat. And they use a lot of water, which gets evaporated once you circulate it. So yes, it's a problem, and unknown problem. That's why they are trying to generate the nuclear power to save some of it. Yeah.
Sir, I have a general query.
Yeah.
Like we talk about the advantages and applications of Gen AI.
Mm-hmm.
Surely it is going to be very helpful in future aspect. But as we know that India is a country with large number of unskilled workers, and surely it is going to be for those who are skilled. They are only going to use that Gen AI and all. And with the growing rate of population, like the numbers are, India is the most populated. So like it is going to increase unemployment.
Okay. So, see, this is also an age-old question, right? I mean, I agree with many of your part of your statement, which are factual. India has growing population, true. India has unskilled labor, true. So there's no argument with that. But when you project it from there, that will it be that the two parts that I specifically want to say that we don't know for sure. A, you said that only skilled people will be using it. We don't know that. That's number one. It all depends on how you or the people like you who are going to be either using it, building solutions out of it, or creating use cases, who do they create use cases for? Do you make it easier for someone who's skilled, or do you use it to create solution for those who are not yet skilled? Right? That's one thing. Second thing, it's always been an issue in terms of whenever a new technology is introduced. Now, many of you are very young. When the computers being introduced in the bank, and I'm talking late 1980s and 90s, they were opposed by like tooth and nail that everybody will lose the job.